Okay, okay.
Good. Good morning, all. We are into experiment 1, and I expect that you must have read the contents of experiment 1. And just because that this is a virtual class, I'm having the first experiment with you. And I want you to move over to page 7 of your practical manual, and we are going to follow through what is being asked of us. This experiment is all about the determination of magnification produced by a convex lens through the variation of distance of image from the lens. B part of it is determination of the focal length of the lens graphically. One thing that goes with this will be, why are we doing this experiment? And that is to say that we are required of two things. There are two aims to this practical. One is to determine the magnification produced by a convex lens through the variation of distance of the image from the lens. And B, to determine the focal length of a lens graphically. Having said this, we now come into the apparatus. What are we going to use to achieve this? At this point, I am going to show you the apparatus. That is the materials we are going to use to achieve these aims. The first thing, you can start from anywhere, but what I'm holding on my hand is a lens. This is convex lens. Look at it, it is thicker at the center and thinner at the edges. I'm sure you are seeing it clearly. This is a convex lens. Next to it is the lens holder, where we are going to put this lens. Of course, you can see the lens holder with the lens together. Another thing is the screen. That's another material, one of the apparatus we are going to use. And then we require a meter rule. We could not make use of the optical bench because the materials are not complete. This is 100 cm rule. That's what we call 1 meter. A meter rule. You can see it. It is graduated. And then, lastly, we will see the ray box. But within the ray box, we have the illuminated object. Unfortunately, because of lack of materials, we may not even have the 10 mm, 15 mm, 20 mm slits. But rather, we are going to make use of the cross wire, which is here. I'm going to show you. You can see attached to this ray box is cross wire. You can see it clearly. And so, these are the apparatus we are going to use. What we are going to do now is that I'm going to set up the experiment. I'm going to set up this experiment. You see me, you get yourself ready of taking values, and then that will be the first thing I'm going to follow. You can see the method, but before the method, I will show you the experimental setup, the diagram, on the arrangement of how the experiment is going to be done. Now, welcome back. Just as I showed you the experimental setup, the apparatus, if you look at the corner of this, you can see the experimental setup clearly, the diagram, how we are going to set it up. But first of all, let us follow what the method is telling us. The method is telling us that we should first find the approximate focal length of the lens by usual method of focusing the image of the window pans on a sheet of paper. The sheet of paper, we are going to make use of our screen, and we are going to make use of our meter rule and the lens. We want to get the approximate focal length. Now, what I want to determine now is I want to use the image of this window pane or the objects outside. If you look at it, you see that this is outside window and objects are the window, outside the window. What I'm going to do is that I'm going to focus